This next chapter is going to be all about rational functions. So we're going to start the same way we start other chapters and just look at what the most basic form of a rational function looks like, and we'll be able to use that to come up with some graph transformations like we've done in previous chapters. And then we'll move on to the normal things. So being able to graph these things, being able to write rational equations, and being able to solve rational equations. So our base function is just the simplest rational function, which is just 1 over x. And if we look at all the different parts that we usually have, inside of our function, we can have something being multiplied outside, okay, our a. We can have something that's shifting our graph left or right. We can have something that's shrinking or condensing our graph in the horizontal, horizontally. And then we can have something that's shifting our graph up or down. So we've got all these parts. So if my base function is 1 over x, let's see where these parts would actually go. Well, if I take a times my function, that's going to take a times 1 essentially. So I'm going to have a on the top. If I add or subtract something to x, okay, my x is on the bottom, so that minus c is going to go down here on the bottom. This plus d is outside of the function. Okay, so it's not down here. It's not down here with the x. It's actually sitting outside here. So that's going to be outside the function. And then we have b, which is being multiplied by the parentheses. So I'd have the b right here. So our transformed function should look like this in order to be in the form we want to actually use it. So let's look at just a couple examples. We'll start off with a real simple example. If we graph our actual base function, I know that y is 1 over x, which means y is the reciprocal of x. So if I make a real quick table, if I put in a number like 1, 1 over 1 is 1. If I put in 2, 1 over 2 is 1/2. If I put in 3, I'd get 1/3. If I put in a fraction, like 1/2, 1 over 1/2 is 2. It's the reciprocal. So whatever our x value is, our y is just the reciprocal of that number. So even if I put in something like 3/4, my y would be 4/3. It's the reciprocal. So to graph a real basic starting function, if I go over 1, so if I put 1 in, I get 1 out. If I put 2 in, I get a half out. If I put 1/2 in, I get 2 out. If I were to put in 1/4, I'd get 4 out, and so on. And these are going to keep getting smaller, so here would be 1/3, 1/4, a fifth, a sixth, all a tenth. Okay, way out there be 1/100th. So you get this curving graph. Okay, and it's never actually going to come into contact with either axis. If I go the other way, if I go -1, the reciprocal of that is -1. I'd have kind of the same look to the graph. Okay, so you get this. So a couple things that you should notice. I didn't make full arrowheads. When you approach a line but never reach it, that's called an asymptote. And when you're graphing and you want to show that you're approaching that asymptote, you put a single arrowhead on. And we actually have 2 asymptotes here. We have, okay, our y-axis is 1 asymptote. That's an asymptote because I can't put 0 into my function. If I put 0 in, I get undefined. So my function can never have a value when x is 0. I also have a horizontal asymptote on the x-axis. And that occurs because I can't get 0 out of my function. Okay, I can never divide a 1 by something and have it equal 0. If I solve this, I'd get 0 equals 1, and that's not true, so it's not possible. So I've got these 2 asymptotes. And that's really the thing that sets rational functions apart for most other functions is you've got these asymptotes. And as we build up bigger and bigger functions, we'll have more than one vertical asymptote, and sometimes we can have a couple horizontal asymptotes. So now if we start looking at our changes, D, that's going to shift our graph up or down. So the most noticeable thing that it's going to change is where our horizontal asymptote is. Okay, so if I've got +5 on the outside, we're in the D position, that means my horizontal asymptote is going to move up 5 places. It would move up to here. Okay, the C shifts our graph left or right. So that's really going to move my vertical asymptote left or right. And then A, okay, is our Y movement multiplier, and B is the reciprocal of our X movement multiplier. Because remember, when you're down here inside the function, all of it's opposite. So if I've got, I'll make a real basic one here, and then we'll graph it just to have a starting point. Let's say I've got 2, and then I've got 1/2. I'll start with it unfactored. 1/2 x minus 1. Just so we don't have the same thing, I'll put a 3 up here. And then we'll plus 4. Okay, so this minus 1 in here, that's shifting everything in my graph to the right one place. So really it's going to shift my vertical asymptote to here, okay, over 1. This plus 4 in the D position moves my horizontal asymptote up 4. So it moves it to here. Now I've got a new starting point. Instead of this was my original starting point that I based all my movement off of, that's moved up to here now. So to get the rest of my graph, I'm going to be looking at how I moved from here, from my original starting point to get to my points. And I'm going to be doing the same thing to get here, except I'm going to take my multipliers into account. So on my original graph, I'd go over 1, up 1 to get this first point. On my new graph, instead of going over 1, I'm going to go over twice that much, because remember, you do the opposite of this. So it's not really times 1/2, it's times 2. So instead of going over 1, I'm going to go over 2 spaces. So that'll put me here. And then I used to go up 1, but now I'm going to go up 3 times as much. So I'm going to go up 3. So I get this point. Okay, the next point I used to go over 2 and then up 1/2. Now instead of over 2, I'm going to go over twice as much. So I'm going to go over 4. 1, 2, 3, 4. And instead of going up 1/2, I'm going to go up 3 times that. So I'm going to go up 1.5. Okay, we can do it the other way too. I used to go over 1/2, up 2. Now I'm going to go over twice that much, so I'd be at 1, and up 3 times as much. So that'd put me up 6. Okay, and here's my transformed graph. I'm going to keep going up that way. Okay, and to switch and get the other side of the graph, we're going to have the same movement, because if you remember, I was going back and down the same amount that I was going right and up. So I can do the same exact movements that I had. So I went over 1, up 6. I can go over 1, down 6. So that would put me from here, from my new start point, back 1, 1, 2, 3, 4, 5, 6. Put me here. Then instead of going over 4, up 1.5, I can go back 4. 1, 2, 3, 4, down 1.5. Okay, and then what was the other one we had? We had 2, 3, so I can go 2, 3. So I get this for the other side of my graph. Okay, and that's basically what we're going to do. So I'll run through some more examples. So we got these three. I've already put in their asymptotes up. This is the red. This is blue. And this is green. Now let's go through graphing these real quick. I'll kind of introduce this table way of looking at it. So the very first thing you always want to do is you want to factor the bottom. Because if you look back at our example, this 1/2 was already factored out of here. In fact, 1/2 is my b, and my b has to be factored out of my x minus c, so that I have the proper c. If I don't factor it out, my c is not going to be the right c. So I'm going to start by factoring. This turns into 3 times x plus 2. So my vertical asymptote has been moved left 2. So you see that's where the red vertical asymptote is. And my horizontal has been moved up 5. So now if we want to use a table to do this, we're going to have our old movement, which was like from our original function. Okay, old meaning it comes from our base function. And this is our new or our transformed movement. Okay, we're going to talk about movement because we're going to be using this as our starting point. And we're just going to be moving from there to get our new points on the graph. So my old movement, I used to go over 1. The reciprocal of 1 is 1, so I'd go up 1. On my new graph, my over movement is affected by this 3. So it's divided by 3. So now on my new graph, I'm going to go over 1/3. And my up movement is affected by this -2. So instead of up, that negative makes it go down. Instead of 1, it's 2. Now if you want to be wise about which numbers you're picking, since I know I'm going to be dividing my x movement by 3, I'm going to pick multiples of 3 to kind of help myself out. So maybe the next one I'll pick will be 3. And then maybe I'll do 6. Okay. In my original function, if I went over 3, I went up the reciprocal of that. If I went over 6, I went up the reciprocal of that. But now that 3 is being divided by 3, so it becomes a 1. And my up movement is being multiplied by -2, so it becomes down 2/3. Now instead of going over 6, I'm going to go over 1/3 of that, which is 2. Instead of going up 1/6, I'm going to go up or down 2/6, which is 1/3. Okay, so this is the movement I'm going to take from my asymptote intersection. So I'm going to go over 1/3, down 2. I'm going to go over 1, down 2/3. I'm going to go over 2, down 1/3. Okay, and I've got my new transformed graph, at least this part of it. And if I want the other part, all I have to do is switch these arrows to do the opposite. So instead of going right and down, I can go left and up. So left 1/3, up 2. Left 1, up 2/3. Left 2, up 1/3. And that'll give me the other side of my graph. So at this point, if you want to pause and try these last two, and then hit play and watch me do it, I'll go through the same steps. First thing we do is factor. So when you factor a 1/2 out, okay, that's the same as multiplying everything by 2. So this becomes x minus 6. So that means my vertical asymptote has been moved over to the right 6 spots. So I've got the blue asymptote there. And my horizontal one's been moved down 4. So since it's 1/2, that means I'm going to be multiplying all my x movement by 2. So it really doesn't matter which values I pick because it's easy enough to multiply anything by 2. But you do want to make sure that your new movement has at least one fractional movement in it. So I'm going to start with an old movement of 1/4. If I used to go over a fourth, that would mean I would go up the reciprocal of that, which is 4. My new one, I'm going to multiply that by 2. So my new over movement is going to be 1/2. Okay, so over 1/2. And my up movement is going to be multiplied by 3. So instead of 4, I'll be going up 12. And then we can pick some normal ones. We can do 1. You know, if I go over 1, I'd usually go up 1. But now I'm going to be going over 2 and up 3. Okay, because it's 3 times 1. So if it even helps you do this, just to remind yourself, multiply this column by 2, multiply this column by 3 to get the new column. Then I could do 2, which used to go up 1/2. Or I could be a little smarter in my choice and pick 3. Because then I can have 1/3, and that 1/3 will be multiplied by 3 to make a 1. So instead of going over 3, I'm going to go over 6. Instead of going up 1/3, I'll go up 1. And I've got some points I can make. So from my intercept, I can go over 1/2 and up 12. So it puts me here. I can go over 2, 3. I can go over 6 and up 1. That puts me here. I get that. And then on the opposite side, we can do the exact same thing. So over 1/2 down 12, which would be way down there. Over 2, down 3, over 6, down 1. So I've got this. Okay, this would be down here. This would come up and approach my asymptote. Then we can do the green one. For the green one, all my y movements are going to be multiplied by -1/2, so it's going to flip them in the opposite direction. And my factored form is going to be x plus 4, and all my x movements are going to be multiplied by 1/2. So I used to go over 1, up 1, now I'm going to go over 1/2, down 1/2. I used to go over 2, up 1/2. Now I'll go over 1, down 1/4. And then we're going to want a non-fractional y value. So I'm going to pick a small number. So, you know, if I went over 1/4, I used to go up 4. Now 1/4 is going to be multiplied by 1/2, so I'm going to go over 1/8. 4 times -1/2 means I'll go down 2. And we can use that movement for my green graph. So over 1/2, down 1/2. And go over 1, down 1/4. And go over 1/8, down 2. Then you do the same thing, only exact opposite direction. So instead of right and down, I'll go left and up. Left 1/2, up 1/2. Left 1/8, up 2. And left 1, down 4th. Oops. 4th. Left and up. So you get this movement here. And this one here. Okay, and that's how we'll do the basic graphing.